In this lecture, we're going to learn how to clear out output when the user starts typing into a text box, and also how to use variable constants inside of our applications. I'm creating a Windows 4 application called Buffet Bill. It's going to be used to calculate a bill for the number of people that attend a buffet style type restaurant. It's going to be a simple application. I'm going to drag on the usual 3 buttons. One for submit, clear, and exit. I want a single text box to allow the user to enter the number of people that will be eating. And then a couple labels, one to output the results, and then another to label the text box, and another to label the results. Dragging over all of them, I'm going to make the font size a little bigger. Resize my buttons. I'm going to use my layout bar, and there's a button called Make Horizontal Spacing Equal. I have all 3 buttons selected. I'll click that and it will space them out. Then another button, Increase Horizontal Spacing. I'm going to click that a couple times to spread those out as well. I'm going to set these labels auto size to false, and set the text align property of them to be top right. And then I will set these out and say number of guests, and this one will say total. I'm going to have to resize these now. I turned off my auto size so that it's false, but now because they're of a fixed size, I can take them and right align them, and now my data is going to be looking that much nicer. I'm going to make this a little bigger, and I'm going to do the same thing with this label here. I'm going to set the auto size to be false. The name of this is going to be LBL total. And I'm going to set the text align of this also to top right. I'm going to take my text box and my label and set their right edges to be aligned. And before I do that, I should actually resize this to fit my placeholder text. But I think it's going to fit. And there. Going around doing the usual submit, clear, and exit. On my form, I'll set my cancel and accept buttons to be my 2 no buttons. I should probably name them first so that it looks nice and I don't have to guess what button 1, button 2 is. So button submit, BTN clear, BTN exit. Now I'll go in and set my accept and cancel button properties. Okay, almost there. On my form load, I'm going to clear out that placeholder text. I'm going to create my exit code right away, application.exit. Might as well do my clear. So this one's going to be TXT. Oh, we didn't name that yet. Got to go back. This one we're going to call TXT quantity. TXT number is not really a good name because that kind of refers to a data type as a number. So go back into that. TXT quantity dot clear LBL total dot text equals empty string, and then we want to return our focus back to that button, to that text box. Okay, it's looking good. We should update our form text as well. It's good to do these in the beginning too so that we don't forget. We call this buffet bill calculator. Alright, let's run it, see what happens. And it looks good. Tabbing through, we can see that our tab order is wrong. This one's first, then it goes here, here, and here. Also, my numeric data is left-lined. We want it to be right-lined because that's going to be a number. So on my text box, I'm going to go to the text align property and set that to right. And then to change the tab order, I go to my view, tab order, and then I'm going to click through. And we can see we're kind of way off. So we want to go 1, 2, 3, 4, or rather 0, 1, 2, and 3. Go back to view, tab order again, we'll turn that off. Let's run it again. And now things are looking good. Okay, so we're ready to write some code. Now, let's do the usual. We'll get this thing running, but what I want to happen is that, let's say that someone entered in 6 guests, and we're going to put a label here that says the price. Let's say it's going to be $10 per customer. What we want is we want to have a way of acknowledging that the user started typing, because what we should have is after we have a total, let's say it was $10, the total would be $60. And the user comes in and they start typing again, they might think that they hit the submit button, and it's going to have an old and inaccurate price according to the new number that's in there. So whenever we do some sort of calculation, we want to clear out the form when they're typing. What we would say is that the form is dirty. The data has been changed, so the resulting output is no longer accurate either. We want to make it very obvious to the user what's going on whenever we can. Let's get this working, and then we'll talk about how to approach that. So what we need, and I left this off, is we need some sort of way of communicating to the users, well, how much is this? So I'm going to copy my label here and put in some different text, and we'll say all diners eat for $10. Or rather, how about this? All you can eat for $10. There we go. That's a good deal. Okay. So, we're going to take the number of guests, multiply it times 10, and that's going to be our total. So go to button submit, and we're going to do our magic formula. I'm going to get some more room here, drag this down, and we have to declare variables. Get the input from the user, calculate. In this case, our calculation should be number of guests times $10, and then output to the user. So going back to our form, we need a number for our guests, and we need a number for our total. I'm sorry, we need a variable for each of these. So 2 variables, double DBL guests equals 0, double DBL total equals 0 as well. Now, going on my form here, I have quantity here, TXT quantity. So probably what I should have here is DBL quantity. We want to make sure that we're consistent. Okay, we need to get the user input for double quantity. We're going to use try parse because we don't want our application to crash. So I'm going to say double. That's the type of data that we want. Try parse txt quantity dot text, because that's the string that contains the data, comma out dbl quantity. Remember, we do out because we want this value to come back out. We want to use this as our container to pass try parse. If it finds the right kind of data, it's going to put that value into this and then give it back to us. For calculate, dbl total equals dbl quantity times 10. We do 10 instead of 10.0 or $10 because it's really just a number calculation. It doesn't care really what it is. 10 is 10 because it's a whole number, but it can also be mixed into math with a double. Alright, lastly, I'm going to output that lbl total dot text equals dbl total, and we know that this wants a string, but this is a double, so we have to do dot toString. Start it up. We forgot to give ourselves a default value. We'll fix that next. Hit 6. I'm going to hit enter because I have my accept button on my form, and it's 60. This would be nice if it was numeric, if it was formatted as a currency, right? So there's two things we got to fix. One, we're going to give ourselves a default value of 6, and then on our submit, what we want is we want this to come back out as money. So we're going to give it that string of C. C's for currency. Remember, we call this a format specifier. It's telling toString that we want whatever's in this variable, but we want it formatted as money. So let's try again, and I'm going to hit enter, and it's looking good. Hit clear, do a different number, and there we go. Only thing missing is we want to do a focus and select all after our button submit. So let's do that. Return focus, and I'm going to say txt quantity dot focus, txt quantity dot select all. We like to put these things in our application because it puts a little polish on it, and it's what the users expect anyways. So for 6, get rid of that, try 4, and we're good. Clear still works, and I'm going to hit exit. So let's take another look now that we have a working application. And what we have here is I got 6, I'm going to hit enter. Now 6 is selected, so when I start typing, it's going to overwrite that value completely. But let's say that I type in 10, and the user comes over here and they think that they clicked it. Maybe they clicked right off, maybe they missed it completely, and they look back on here and they say, oh, it's $60. And they say, oh, well, hey, maybe the program's broken, maybe they changed their cost. It doesn't really matter. But now what's happened is that you've introduced some doubt into your application that maybe it doesn't work right, or worse, the user actually thinks that's the money and someone gets charged wrong. So what we want is when someone hits enter, it outputs the proper answer, but when they type, we want to clear this out so that they have to go and hit submit again to get the new answer. And so just like we are able to cause code to execute when the form loads, and we can cause form to execute on a button click, we can also cause some code to execute when someone types into a text box. And just like the form and the button click, most of the things that are interesting in .NET in terms of events, you can get to by double clicking in our designer. So when we double click a button, it causes that button click event code to generate. Same thing with form load. When we go onto our text box and double click it, it creates an event called text changed. And it's named just like our other events, whereas this would have been button submit click. Well, we can see it's txt quantity text changed. And this is going to fire when someone starts typing. And so what did we want to do? We wanted to clear out the results in that label total. So going back over here, double clicking on our text box again, this code works just like anything else. So if we want to clear out our total label, we say LBL total dot text equals quote code. And so let's try it. Hit enter, and I'm going to start typing 23, and look, it cleared it out. Hit enter again, 5. Cleared it out. It forces the user to either press the enter key or to hit the submit button to get their results. 2, 1, 2, 3. Enter. Okay, that's a lot more, right? But we would not want the user to think that 6 people is $2,000. So this is a very good thing to build into your applications. It makes it a nice, solid app and a good user experience as well. Now, this is a pretty good app. We got a lot of things going. We put all of our bells and whistles. It's got a nice polish to it. But one thing that we don't really have is the ability to change our pricing scheme on here easily. And when I'm talking about pricing scheme, I'm kind of referring to the idea of everything is $10 on here. And so we would have to change this in 2 different spots, really. We'd have to change it on the label on our form, and we'd also have to change it in our formula right here as well. And so when you do calculations, you really want to try to avoid putting important numbers directly into the equation. When I say important numbers, I mean the fact that this is the price. And if you think about it, the whole application is really dependent on that one price. And so because it is so important, we want to sort of treat it special. And to do that, we're going to create a special kind of variable called a constant. And the idea of a constant is sort of contrary to the idea of a variable. Variables are containers that can hold values that are going to change, whereas a constant is a special kind of variable that you're not going to change for the whole life of the application. We would say that this is really hard-coded in there. The way that variables that are declared as constant work in memory is also a little different. You get a better performance for declaring certain variables as constants because it doesn't have to be in a place where it's going to change as much. And so what we do is, whereas we would type double, let's say double cost equals 10 as a normal variable, with a constant we put the keyword const in front of it. And what this means is that it is a constant now. We also do a little different naming for constants as well, because we don't want to get them confused with normal variables. We don't do prefixes on constants. Instead, we do all capital letters. And we say, I'm going to call this one cost. If your constant has multiple words in it, you also do a capitalized. Let's say that we call this guest cost, but instead of doing a camel case, which we can't because they're all capitals, we put an underscore in between each. And so you can tell by looking at these two that there is quite a bit of difference between what this one looks like and what this one looks like. And so how do we use it? Well, we use it just like any other variable, but instead of having the numbers 10 in there, I'm going to say guest cost. And so we can see here that, okay, we have double quantity, but then we have guest cost here, and that just looks more important, doesn't it? So let's try running it. Hit submit, and it works exactly the same as it did before. But this is one of those best practices thing. In this application, it's important because the number 10 is so important to the application. It's driving the whole cost of what the actual result is. So why not declare everything constant then? Well, because it loses its ability to be able to change its value. And so what am I talking about? But let's say after that line I changed my mind and I wanted it to be 12, for example. Well, I would do it just like a normal variable, except now I'm getting the red line underneath. And if I mouse over it, it says the left-hand side of an assignment must be a variable, property, or indexer. And so you're thinking to yourself, well, I don't get it. It is a variable. But it's not anymore. It's a constant. And so we can't ever change it while the application is running. I could change it here in the initialization statement, but I can't change it past that. It has to be set right in the beginning. And so that's the idea of a constant, and we have our application now. And it's a better practice because it is so important. So what else do we have to change? Well, our comment isn't really accurate anymore. We would say number of guests times, and this is okay because it is important and it is pretty obvious what it says. We can do that now. What else? Well, we got this label up here now, and this label says all you can eat for $10, and that's not really what we want either, because then every time we change that price, let's say it's $12 now, we'd have to change that too. So what if we were able to feed into this label using our constant? And this takes a little creative thinking. And what if we did this? I'm going to take that $10 off of that label, and then I'm going to copy it, and we're going to make this one dynamic. So I'm going to say LBL cost. Now this label is still right aligned. We want it to be left aligned now because it's going to be, we want it to be right up against that other label. Okay, so far so good. Let's see, so then in here, because we're declaring it, we can just put another line, and we can say LBL, oops, where is our label? We didn't name it. Changed the placeholder, but I didn't name it. LBL cost. Going into my button submit as my shortcut right here, I'll say LBL cost dot text equals, and let's say guest cost, and it's still a double, although it's a constant, it's still a double, so we can say toString C. Alright, let's try it now. Oof. We put that on our button submit, didn't we? So if I hit submit, now it works. Well, we don't want that. We want it to be on the form load, don't we? So I can take this whole line out here, and maybe I'm going to move it into my form load instead. Oh, another problem. Problem is that constant doesn't exist inside of my form load. We use the word scope, right? Scope is referring to where it's defined, and down here inside of my button click is where it's defined. And so because of that, I can't access it up here. And so the immediate thought would be, well, gosh, why don't we just copy this line out and paste it in here instead? And that works. However, we're kind of back to where we were before, in that we didn't want to have to change this in multiple spots. So what do? Well, this brings us back to the whole idea of scope again. And up to this point, we've been declaring all of our variables to be within a function scope. We'd say they're local variables. But it's possible to declare a variable outside of all of these functions. And we would declare it at the class level. And this is all about these brackets here. So whenever we have a function, for example, form load, we have a start bracket and an end bracket. Well, all of these are within the class brackets. So if we put it outside of one of these functions, we're able to access it inside of every function. So I'm going to Control Z so that it's no longer in my form load, and I'm going to scroll down to my button Submit, and I'm going to take this, right click, cut, scroll up, and right after the beginning of my class, after that opening bracket right here, I'm going to paste that. And now what I have is a class variable. And a class variable is able to be accessed by every function. Now, this can be abused. And so at this point, we're only going to use this to declare constants that are in multiple spots where they need to be used. So let's scroll down to form load. This is working. Scroll down to button submit, and I can see this looks like there's no errors there either. So let's hit start. On form load, we have all you can eat for $12. That's perfect. Looks like it's been there the whole time. Hit submit. 72. 6 times 12 is 72. Let's try a different number. 5. Great. Let's exit. Say we get a call from the boss and says, you know what, $12 is too much. Let's drop it down to 10. Gonna hit start. And now I can see this says 10. Hit enter. 10 times 6 is $60. So when you're using one variable in multiple spots and it's not going to change, we should declare it as a constant. From our miles to kilometers program, this would have been great, especially since the conversion rate from miles to kilometers isn't ever going to change. But if we needed to change it, we would change it in a single spot. Okay, so we have covered text changed, constants, and we're going to do one more, and that is the idea of alternate access keys. And so up to this point in our application, we have something that will fire on an enter key press. It'll go for my accept button. I have something that will fire on my escape key press, which fired my exit, which is a cancel button. But there are also some other keyboard shortcuts we can do. And what these are is the idea that if you hold down your Alt key, you'll notice that some applications will actually give you some shortcuts. And even if you do it inside of Visual Studio, I don't know if you saw that or not, try it on your computer, but if you let go and press it again, watch right here under File. If I hit Alt key, it underlined the F under that. It also underlined the E, and most of these are the first letters. Sometimes it'll be a separate one. Those are our alternate access keys. If I were to hold down my Alt key and press F, it's going to open up the file menu. The reason it's doing that is because you can see that underneath the F there's an underline. And you can try this in just about any Windows program. The catch is you'll notice that no letter is underlined more than once. Even though this format starts with an F, the access key for this is, and it's lowercase o. So Alt O is going to open up that menu, and you can see within that menu there are more of them. Again, Alt F is opening up my F for file, and then I can hold down the Alt key again, oops, and do O for open, and then it's going to shoot out another submenu. And it turns out that we can do this as well, and it's very, very simple. And when possible, you want to try and use the first letter of each of these, unless you start running into things where you have two buttons and they both start with the same letter. But this is how we do it. So I'm going to go into my submit button. We want this to be S. So it's as simple as going into the text property and putting your cursor before the S, and we do an ampersand. An ampersand is the shift key and 7. And so what it did is I put an ampersand before the S, and I'm going to hit enter. And you'll notice it did not put that same symbol in front of it. Even though it's there in my text property, now I can see that my S button has an underline under it. So I'm going to hit start. My app looks just how it always does, but holding down the Alt key, Now I have the same thing. And then pressing the S, and it's the same action as if I was hitting enter or if I was actually clicking my button submit. Going through the other ones, I'm going to want to do the same thing. So for clear, in the text property, before the capital C, I'm going to do Shift 7 for ampersand. And then also for exit, some people would do an X for this. I'm going to do a capital E, Shift 7 ampersand, and hit enter. Now I'm running it, and I can see, holding down the Alt key, I can do C will clear, type in 6 again, Alt S for submit, or Alt E for exit. And so when you have buttons or menus in your application, it's always a good idea to go right off of this. Not everyone likes to use a mouse for the application. Some people are really feel a lot more strongly about just using the keyboard when they can, because it is faster. You don't have to reach over, you don't have to move the mouse. You're able to memorize these shortcuts inside of an application. So we're going to want to use these alternate access keys in all of our applications moving forward.